apologize. And we're a data privacy engineering company. So we're the creators of Fides. It's an open source privacy engineering platform. And I'm here today to tell you a little bit about how you can embed privacy by design directly in your data infrastructure and your distributed systems. So I would say we've got a lot to cover. I'm going to go really, really quickly. So I'm going to apologize in advance. Everything you see here is available in documentation online, and there's links throughout the deck. So don't panic, you can get copies of everything, because I'm going to go very fast, and I apologize in advance. So we're going to cover what is privacy as code conceptually, like what does it mean and how does it work, an overview of Fides, the open source tools, and then we're going to do 2 use cases live. So of course that's going to break and egg on my face, but we'll do our best to get through it all, okay? So a little bit about privacy from a point of view of engineers, right? Privacy is pretty broken, right? For most engineers, it represents pain and friction. You probably know this already if you're dealing with it. The world of privacy is dominated by legal regulations that are pretty painful, right? From the CPRA in California, the GDPR in Europe, the LGPD in Brazil. Basically, a whole bunch of acronyms that don't mean a lot if you're a data engineer or a software engineer, but they do affect the jobs we do, right? 9 out of 10 companies in the US, mostly venture-backed tech companies, don't have any automated solutions for data inventory or data privacy orchestration capabilities. So they're rolling their own solutions or doing it manually, right? It's really labor-intensive, it's really costly. If you're familiar with this idea of privacy rights requests, or sometimes called DSRs, so the right of a consumer to say, give me my data, delete me from your systems. I see someone smiling, they're obviously familiar with this pain. The average time it takes a company in the US is 83 hours, right? It's like a giant Rube Goldberg machine, right? Like request comes in, tickets go through the organization, and engineers run around spelunking for data. There is hope though, right? If you use the tools that I'm going to show you today, the average time for a privacy request is 17 seconds over the last 3 years, right? And we have customers that have done 20,000 requests a month, right? So this scales, this really scales. It saves engineers a lot of time. So please, please trust me. From a cultural perspective for us as a company at Ethica, we believe privacy is a fundamental human right. And that kind of sounds like a bumper sticker, but it's really important, right? Privacy really matters. The problem for engineers is we care about privacy, but mostly it's really complicated and really painful, right? Like it's not a smooth process. The reason for that is the way privacy is handled today, right? In most cases, privacy looks like this, right? The wonderful, virtuous, agile software development lifecycle happens, right? So we design, we implement, we hopefully test in QA really, really well, and then we deploy. And once we deploy, we start to collect human beings' information. And it's sometime at that point, when we've collected some people's data, someone goes, hang on, we probably have a privacy problem, right? So that's the point you bring in the lawyers, because you don't really know what to do. And the lawyers say we need to do data discovery. That's basically spreadsheets full of data labels, right? We need to do data mapping. We need to do privacy reviews, risk analysis, product design council reviews. We need to manage consumers' rights to consent and rights to access and erasure. All of this stuff, right? Really complicated. Basically, for developers, it's pain often caused by lawyers, right? The 2 things just don't align. I hope there are no lawyers in the room. We don't present that to lawyers. The law creates a lot of complexity, right? These are all acronyms that exist in data, like DPIA, DSR, PIAs. The list goes on and on, right? Understanding purposes of processing, et cetera, lawful bases for use of data, this kind of stuff. Engineers shouldn't have to deal with any of this. It's not our problem, right? So as engineers, what are we trying to accomplish when we talk about privacy? Well, it actually boils down into 3 simple things, right? You want context, right? Like context over your systems. And when I say context, I mean describe the type of data we're using and what we're using it for. Lawyers will call it like inventory and cataloging and mapping, but we basically just want to know what have we got, what are we doing with it? We then want to manage the risk, right? Like in the same way that we do threat modeling for security, with privacy we want to identify, are we doing a thing that might put our users at risk? And last, if we've accomplished both of those, we want to make sure we afford our users their rights, right? Like rights to access their data, to delete themselves, to manage consent. Now, I'm oversimplifying. There's a whole bunch of other complicated legal stuff, but as an engineer, this is the stuff we should be worried about, right? Not filling in forms for access to data. So privacy as code as an approach is this idea that you can create effectively a layer of your tech stack, right? Like a fundamental set of tools, right? A software development toolkit that's implemented directly in your stack that takes responsibility for addressing all the legalese and legal speak so you can focus on being a sort of very agile developer. And I'm going to show you those today. They're called Fides. Fides is named after the Roman goddess of trust. We've been working on it at Ethica for nearly 4 years, so 3.5 years. We only published the first release publicly in November last year. So it's taken a long time to get to where it is, but it's a pretty mature set of tools today. And its promise is essentially to solve all of the work that engineers do in privacy today with a set of tools that make it streamlined and consistent across distributed systems. The simplest way of thinking about the open source tools, right, what is publicly available, is a language. So it's a description language, right? It's mostly written in YAML files. I'll show it to you in a moment in dot notation. We call it Fides lang. And sitting on top of that are a set of tools, right? So there's Fidos Control, which is a metadata server and a policy engine, as well as a CLI tool. And again, I'll show you that in a moment. And then there's Fidos Ops. Think of Fidos Ops as a runtime data orchestration tool, specifically for privacy types of requests. And again, I'm going to show you these live in a moment. So just to orient you on the parts of the system. Right? The language itself is very simple. It's intentionally simple, right? If you go and look at it, it's available at Fides, so fid.es/taxonomy. And if you look at it, you'll see that it's a very, very simple description language. It allows you to essentially describe data across 4 dimensions: the type of data you're handling, the purpose for which you're using the data, who owns it, like is it an employee or a customer, and then the risk of re-identifying an individual, essentially. And we're going to go through that in a bit more detail now in a minute. So in terms of writing what we call Fides declarations, it's very simple, right? Like it's dot notation. There's some snake case in there just because we were struggling with grammar, but it's pretty much dot notation, I promise. And so for example, if I wanted to describe that a piece of data was being used for systems operations, I would do exactly that. It's system operations data. If I distinctly wanted to annotate or label a piece of data as an email address under the GDPR, I would call it user provided identifiable contact email. It's very, very simple. It's pretty human readable, right? Like anybody could look at this without any knowledge of it and know how to label an email address. So let's go into the major primitives of Fides, and we're going to dig right in so I can show you some demos. So conceptually, there's sort of 4 core primitives. They're organizations, and think of this as the scope within which risk is evaluated. So an organization could be a business unit, right, like an engineering team, or it could be an entire company like Acme Inc., right? And when you design a policy for risk evaluation, it operates at the scope level. So you could have multiple teams with evaluating different risks. So those are organizations. Then you've got systems. Systems are exactly what they sound like, right? They're, in the simplest form, blocks of code performing logical tasks, right? System could be a single service, could be a monolithic application, could even be a database. It's a system. Distinct from that are data sets. Data sets are collections of information, right? Could be a database, could be an API, could be a list of anything, right? So it's just collections of information. And then finally, you've got this concept of policies. And they are what they sound like. They are YAML declarative style policies that you want to enforce. We permit the use of data in certain ways, but not in others. And I'll show you that again in just a moment. Okay, then we get into the taxonomy itself. And this is the last bit of learning we'll do, then we'll go to show and tell, I promise. So there are 4 sort of common canonical taxonomy representations in Fides. There's the data categories themselves. So what type of data am I processing, right? So what is it? Is it email addresses, behavior data, names, etc. Data subjects are the type of user, so the who. Is it a customer, an employee, a patient in a medical system, etc. Data uses are how is the data being used, right? Am I using it for behavioral analysis, for advertising, just to provide the service of the system, etc. And then data qualifiers. So this is how re-identifiable a human being is in a system, right? Is it fully anonymized data? Is it pseudonymized and unlinked? Is it just identifiable data sets, right? So the risk of re-identifying a user. So with these 4 primitives, that is to say the organizations, systems, and so forth, you end up with the ability to describe any set of data and what you're doing with it. And you don't need to know anything about privacy laws, right? As an engineer, I don't need to ask a lawyer or anything. I can simply describe the data I'm handling. An important point to note, all of this looks very manual and very labor intensive. There's a lot of tools that automate these tasks within Fides, right? But here we're just working through the primitives. Okay, so with Fides, what we've learned so far is we can essentially describe the type of data we're handling in a system, the purpose for which we're using it, who it belongs to, and then describe a policy to enforce on that system semantically, right? So we don't need to speak to lawyers. And I'll show you real examples of that in just a second. So again, a reminder, we've got Fidos Control, which is essentially the metadata server and policy engine. It hooks into your CI pipeline, so it's automating tests essentially for privacy. So think of it like unit tests for privacy or static code analysis for privacy. And then Fidos Ops, which is a runtime orchestration tool. Okay, and we're going to try and show you both of these in the time we have. I know I'm going very quickly. That's intentional. So the first use case we're going to use is Fidos Control. So Fidos Control runs on the left side of the software development lifecycle. So that is to say the code management environment, not the runtime or deployed environment. Okay, so it's a metadata server that allows us to evaluate risks. Now, what do we mean by evaluating risk? So first of all, let's just look at the components. This Fidos Control database is just a very simple database. You can deploy it to anything. By default, it just runs with Postgres, but you could use anything. There's the Fidos Control web server itself. and then it hooks directly into your CI pipelines, or you can use your local CLI to run commands against it. It's very API-driven. It's a very simple tool. It's very well documented. To get it up and running, very straightforward. As you can see, super simple config files. Just point out the database you want to use and instantiate the server. The GitHub repo is at fides/control, and the docs are at fides/config. In terms of the commands, there's about 20, but the ones that are most interesting in terms of what we're talking about today are the apply, evaluate, generate, and scan. So I'm going to go through them in slightly out of order here. So generate allows us to generate a dataset declaration file about resources that we have. So what I mean is instead of labeling data manually, you can actually point the Fidos Control server at a storage system, and it will use the DDL to generate a YAML declaration in Fidos language of the types of data that are there. So you don't need to do it yourself. From there, you can evaluate risk, and that's what this part of this demo is about, is evaluating risk and enforcing policies. So we're going to do some of that. This looks intimidating, right? This isn't ours. This is the Data Protection Commissioner in France, and the one in Ireland and the one in the UK. They have similar documents. This is their recommendation for what developers should do to address risk evaluation when they're building software. So before you submit a PR, you're supposed to do all of this, right? And this giant Rube Goldberg machine basically says you're supposed to understand what type of data you have, what you're using it for, in the same way that you do in threat modeling for security, identify the risks that might occur if you use the data in this way, and then mitigate those risks, right? So like, are we allowed to use behavior data and location data together to infer something about our user, or might that create a risk? We as engineers don't really know, so we rely on the lawyers to tell us. The lawyers don't understand what we're doing with the data, so this sort of incredible mechanical Turk ensues and nothing gets solved. The average Bay Area company that does privacy reviews takes about 6 weeks to conduct one. So most just don't do it, right? That's what happens. It's a really painful process. So in Fides, we invert this, right? Instead of having to know all the laws, we create policies that we can enforce in our CI pipeline. So an automated check. So in order to do this, what we want to be able to do is essentially declare what type of data we're processing and storing, right? What we're doing with that data in our system, like how we're using it. And then we want to check that we're not using it in a way that doesn't comply with a law or a policy the business has, right? So that we don't make a mistake. And we want to do this in a really streamlined way. So in order to do that, I'm going to jump out of this deck and go straight to VS Code and show you an example of this. So what I'm running here is the Fides demo project. You can find it publicly. It's the Fides demo repo. It's got a bunch of make files, so you can spin it up in about 5 minutes. It's very easy to use. And the contents of it at a sort of simplistic level are this. Let me zoom in a little bit. There's basically the Fidos Control web server running, okay? There's the Fidos Control CLI. There's the Fidos Ops web server, which is the data orchestration tool. And there's a fictional e-commerce application in this demo repo, right? So it's there intended to sort of replicate a simple version of what a developer might encounter. And that's what we're going to use for this demo. So I can show you the app. It's a very simple Flask application. It's not going to win any awards, right? It's a pretty ugly e-commerce app sitting on top of Postgres. But the point is, if I buy something here, my data flows through it into Postgres and then probably on to 100 other sources, and I'm going to deal with the privacy problems, right? So it's a microcosm of an example of what happens at scale in most companies, right? So behind this, if you recall when we rushed through the primitives of Fides, are a bunch of declaration files. One that describes the system, my e-commerce application, and one that describes the data set, in this case, my Postgres database, right? So what we're going to do is look at those very quickly and orient ourselves on how they're structured, and then we'll run some CI checks. So what you'll see here is the system declaration. Now, again, this is a pretty simple application, right? So there's one system declaration. Again, remember, a system declaration could describe a single service in like a service-oriented architecture or an entire app. It's just a stylistic decision. In this case, you can see it describes this simple Flask web application. We've given a simple human-readable description. And then we've got our privacy declaration. Now, in this case, what we've said very simply in plain English is it's an e-commerce application. That's all it is, right? We've then described a little bit about it. We've said we're handling a couple of types of data. Now, as a developer, I don't know a lot about privacy, so I've just said, well, I think I've got some data they provided to me that's identifiable. And we've probably got some data we've derived or observed about the user. Pretty simple declaration. And we have some non-personal data, some systems operations data, timestamps, et cetera, in here, right? And what are we doing in this system? What's the use? Well, we're providing e-commerce. We're not doing machine learning modeling. We're not doing advertising. We're just doing e-commerce. It's very simple. So this is our system declaration. Now, distinct from this, we've got our data set declaration. Now, it's a very simple Postgres database, right? You can see it's got 3 tables, so it's super basic. We've got products table, purchases, and users. Now, if we look at the users table for a moment, again, a very simple one. It's just got 3 fields, or 6 fields, 6 columns. We've got created at, email, first name, ID, last name, and password. We're all familiar with what these are. So created at is a timestamp. It's not personal data. It's not risky. So it has been annotated as system operations data. So we've just declared it as system operations data. Email address is declared as you'd expect. So user provided identifiable contact email. But here's the thing. If I'm a developer who knows nothing about privacy and I don't even know what kind of data I'm dealing with here, I might just say, actually, this is user data. That's all I know about it. Now, it means we can only evaluate policy and risk at the user level, very abstractly. But I might say it's user-derived data. That's all I know about it. Or, like we had, it's user-provided, or maybe identifiable. I could stop there. I could then say it's contact or email, right? And we'll leave it as email for now. Now, I'm not running a CI pipeline locally here. This project is just running in a container on my computer, and that's why it'll probably crash in a minute. What I'm going to do is force an evaluation. So if I were to commit this code in a fully formed CI pipeline, it would spin up the Fidos Control server and run an evaluation, okay? So we're just going to run it by hand. So it's going to whiz past, so I'll explain what's happening here. So you'll see that it's grabbing all of the newly committed code, my dataset declaration, my system declaration, and you also notice it's grabbing with a policy resource. It's applying that, it's evaluating it, and then it says evaluation is passed. We're green and we're good to go, okay? Pretty simple. There's, nothing's unusual here. Now imagine I continue working on this project. For some reason, as an enterprising engineer, I decide, actually, I'm not handling email address here. I'm handling some health and medical data. Pretty weird thing to do in an e-commerce system, but I might need to do that, and I don't know anything about the law. So I'm handling some health and medical data. I've declared that. I'm going to rerun my commit or my evaluation. The evaluation runs, we get a big red error message. Okay, whoa, everything stops. Now, it can continue with the commit, or it can just generate a flag for the engineer. And what it says here very simply is, hey, you're attempting to use a sensitive type of data for this e-commerce system, and we have a policy in place that says you cannot use sensitive data, particularly not health and medical information. So let's look at the policy that's actually driving this, right? So behind this, there's a simple Flask policy. Let's tidy it up for a second. So you can see there are 2 rules or conditions here. One is related to what we call data minimization. So in GDPR land, they say purpose use limitation, which basically means making sure developers don't use the wrong type of data for the wrong things, right? But knowing what data you can and can't use is almost impossible if you're not a lawyer. So the other rule is rejecting sensitive data. And what this simply says is, hey, we're going to, for the purpose of example, we're going to reject the use of any sensitive data. So if you attempt to use any of these categories of data, of biometric, children's, genetic, health and medical, religious, et cetera, for any of these purposes, so for any of these uses, just providing the system, improving it, training an AI system, collecting the data, that's a hard reject. We don't permit that. Now, you can write complex compound policies with exclusions under certain conditions. You can say, well, we can use certain data types in combination for certain purposes, but not for others. The key thing, if you think about it, is instead of doing a privacy review where you fill in a form, send it to the lawyers ask lots of questions, they send it back, you don't understand their questions, and eventually send another form, and we do that for 5 weeks in a product review document. The difference is here, we just declare what data we're handling in our data sets. Those policies are pre-written, preloaded in our CI pipeline, and they're just checked for us, so we don't have to worry about it. Now, the other magic trick that's happening in the background is each commit here is augmenting a metadata server. So the Fidos Control is a system of record with a very, very complex metadata server that's maintaining a view of all distributed systems. So anything that gets annotated augments that metadata server. So if you've had to be involved with the painful process of doing data mapping or annotations of data sets in runtime systems or production systems where lawyers say, tell us what's in anything from Databricks to Redshift to Postgres to BigQuery, you'll know that it's a painful, slow, mechanical Turk. But each of these small incremental annotations with each commit or each PR is effectively augmenting a data map. So you can export reports directly from this to lawyers that gives them all of the data they need. You don't need to write anything else. You don't need to manage a spreadsheet. It generates all of those for them. In fact, there's a paid UI that sits on top of it so they can get those reports themselves without ever speaking to an engineer. Or maybe a better way of putting that is an engineer never has to speak to a lawyer, right, which is the whole point, really. So what we've done in this simple example, right, is we've declared what type of data we're processing and storing, what we're doing with it in the system, and we've checked it against a simple policy, and it's told us what we need to update to be able to continue working forward. Okay. So the next one we're going to talk about, with the few minutes we have left, is programmatic data rights. It's this idea of data subject requests, or DSRs, right? So, hey, delete this user consistently from this system and don't break all of our data pipelines afterwards, right? Like, that's the default problem. So how do we do that? How do we ensure that we can build a scalable orchestration tool that will delete data consistently across distributed systems and ensure that even if we modify the data model over time, right, like we make updates to our systems, we can still continue to delete or retrieve that user's data consistently? And how do we do that and make it configurable? Like, what if we want to control the hashing or anonymization mechanisms or the types of data we want to erase? It gets really complicated, right? You basically roll your own services and you have to maintain them as you modify other things in your data model. So Fidos Ops was built to address this problem, right? First of all, for those that aren't familiar, this is what data subject requests look like, right? So it's basically paperwork that lands on a lawyer's desk or as a ticket in Zendesk or Jira, right? Like it's, hey, someone wants to be deleted or wants to retrieve their data. And as a company, you've got sort of, if you are in a company, you've got 30 to 45 days to complete this request to be compliant with the law. What it basically looks like is this. User request comes in legal parlance, they're called subjects. That's why it's DSRs, data subject request. So the subject's request comes in, maybe an email, maybe a ticket, maybe a support inquiry, a phone call. Frontline customer support are trained to check that the person is who they say they are. If they confirm that off, right, they can then generate another ticket into an internal ticketing system, Jira or Asana or wherever. Then engineers have a bunch of runbooks. Maybe they execute this on transactional databases. Maybe they wait for data to expire in an iceberg somewhere. But effectively, they get rid of it eventually. And then eventually, they confirm that to the frontline customer support teams and the legal folks, right? Like a giant Rube Goldberg machine, literally, right? So what happens with a tool built for this, right? Well, we can construct a request policy. So we actually describe what we want to do. We can create that as a rule and enforce it in one area of the world and have a different rule for another part of the world, or based on different conditions about users or business policies about systems. So we can retrieve it, collate it, and return it to a user, and we can consistently erase it. So in this example, what I'm going to do is demonstrate that. I'm basically going to use a standard request policy. We're going to retrieve the data about a fictional user in this e-commerce system that we've been playing with. We're then going to make a simple development change to that system that's going to affect the data model in production. And we're going to rerun the request and see what data is returned about the user. So you can see how quickly it's sort of synchronized. OK, so in order to do that, we're going to describe this. So let's go. Let's run a privacy request in our e-commerce system. So we've got a fictional user in here, example user at ethica.com, right? So we could log in, we could buy a product. I've already done that. So there's some data about this fictional user in Postgres. So there's an off-the-shelf React app that sits on top of this that you can basically spin up, or you can build your own with the APIs that sit on top of the ops orchestration tool. But this one runs just fine. So I'm going to use example user at ethica.com. I'm going to submit that request. And we're going to go to the admin tool. Now, the admin tool sits directly on top of Fidos Ops, the orchestration tool. And this is for non-technical users to process these requests, right? So if we look, we've got a new access request here. And if we reveal the PI, we can see the name of the user is example user at ethica.com. So we can approve or reject this request, right, as a business user. So I'm going to go ahead and approve it. And what's going to happen here is it's going to collect up all the data about this user, and it's going to dump it here as a JSON package. I'll just open this up very quickly in VS Code so that you can see it. You can see it's very simple. It's returned data from the primary users table, first name and last name, and their purchase address. That's all it's done. It's a very simple example. Now, let's go back to the application as a developer for a moment. If you remember, we had a Postgres data set here, and we had contact email address. And then we also had this created at timestamp. Now, created at timestamp isn't personal data, but let's, for the purpose of proving that this sort of orchestrates very efficiently, let's decide that created at, we've made a new business decision. It's user-provided, identifiable contact information. Let's declare it that way. And let's go and rerun the request, right? OK, so all we've done is processed a new privacy request. We can see the one's flowed in. We're going to approve it. And it's going to generate another JSON package. And if we just open that up, we'll see here now that it's returning the timestamp as a piece of personal data. So basically, any change that we make in our software development lifecycle is reflected instantly in the production data model. And the policies that we've enforced allow us to return that data. And we do the same in reverse. We could say, well, actually, we want to return email addresses, phone numbers, and names, but retain order history, because we need to keep that because our accountants have said we need it for tax purposes, for example. So you can generate these policies and impose them across distributed systems. And what's actually happening under the hood in Fides Ops essentially is the ability to generate an identity graph across systems, link either manually or automatically, depending on the tooling you're using, the foreign keys between those, and then generate an order of execution. And it basically builds a dependency graph and then effectively a deterministic set of queries. And you can pre-flight those so you can see what it's doing before it ever executes them on your systems. And then as your data model evolves, we'll continue to execute those consistently. Or if your legal team want to update the regulations in any way, they can generate a new policy and we'll execute those on whichever systems you want to execute them on. So what we've done there is basically construct a request policy, retrieve data, and collate it from those systems. We made this minor development change to affect the data model, and we rerun the request, and we returned this timestamp as personal data in this example. Very, very simple. The next thing that we're adding to Fides are essentially what we call helpers. There's a machine learning classifier that's about to be released that automates labeling, so you don't have to label anything manually. It's effectively been trained on personal data for the last 3 years. And there's a UI for non-technical users to better visualize and manage data maps in the taxonomy. And there's a bunch of other tools that we're building over the next 2 years that address things like attribute-based access control systems and risk evaluation in the runtime environment. So I guess as a conclusion, we've covered what is privacy as code as an approach, an overview of what Fides can do, with 2 examples, both checking a policy in our CI pipeline and automating a data request. Now, we did an access request. We can easily do erasure as well, but that's all we'll do for today, I think. It's very easy to get your teams running and using these tools. Fides, as I mentioned, is completely free. It's essentially mostly Python-based. You can get up and running with the quick start guide in about 15 minutes, and there's nothing much to learn because the language is pretty declarative. It's very basic. And there's very solid documentation available publicly, and then there's a Fides Slack community. I'm happy, of course, to answer any questions you have, or get any feedback, or have you open issues on the public project. Thank you so much for your time. Happy to take any questions. And if there are no questions, I'll let you run away early. That's okay, it's the end of the day. But what I would say is the deck is available at Fides/Databricks. And if you want to join the community, it's Fides/join. So thank you so much, everybody.